assume that no heat is lost to the surrounding. A final temperature of 50 Celsius degrees could be obtained by mixing equal masses of. We know that to obtain the mid temperature as the final temperature, we have to mix two materials with same condition, same material and same temperature. Same temperature difference. It means we can mix both at 0 degrees and both at 100 degrees with the same mass. Then we can obtain fifth one is the correct answer. A certain quantity of crushed ice at 80 degrees is heated at constant rate until all the ice is converted into steam. The specific heat capacity of water is greater than that of ice. What of the following graphs best represent the variation of temperature with time? There is a constant rate of heat absorption. Then we can get, they have given specific heat capacity of water is greater than that of ice. It means it is difficult to increase the temperature of water. Therefore, gradient of this part, it is represented in ice, should be greater than gradient of this part. This part is increase in temperature of water. And we have to get that latent heat of fusion, it is represented in this part. Time taken to fusion is less than time taken to vaporization. Then we can obtain fourth one is the correct graph. A lead bullet moving at speed 130 meters per second is stopped inside a block of wood. The specific heat capacity of lead is 130. If all the energy goes into heat in the bullet, the increase in temperature of bullet is. We can get kinetic energy of bullet half mv squared should be converted to heat energy ms theta. We have to find increasement of temperature, then I will subject theta v squared divided by 2s. V means velocity. Velocity is given as 130 meters per second. 130 into 130. We have to substitute 2 times because of there is a square term. 2 times specific heat capacity also given as 130. Then we can cancel out 130. 130 divided by 2 means 65 degrees Celsius. Then answer is 3. A metallic vessel containing a certain amount of water, is heated uniformly at a continuous rate, constant rate. If the heat loss of surrounding is neglected, then the rate of absorption of heat R by the vessel when plotted against time T is represented by. We can consider for the initial situation there is a constant rate of heat absorption by the container because of heat is absorbing by the container and water to increase its temperature up to 100 degrees. After the temperature reaches 100 degrees, total energy is used to increase the potential energy of water. It means it is vaporizing. Therefore, temperature of the container is a constant value. It means there is no heat absorption by the conductor. It means container. After that, after vaporization, we can observe that vapor is increasing its temperature. But we know that it is easy to increase the temperature of vapor than water. It means a small amount of heat is absorbed by vapor, but large amount of heat is absorbed by container. Therefore, R should be a greater value than this one. It is the temperature R with T. It is the graph R with T. Equal amounts of heat was given to two liquids A and B, mass M and M over 2, respectively. The liquid A has 1/2 the specific heat capacity of liquid B. If the increase in the temperature of liquid A and B are theta A and theta B respectively, we have to get the relationship between theta A and theta B. There are two liquids A and B. Mass of A M, mass of B M over 2. And liquid A has 1/2 specific heat capacity of this one. It means if the specific heat capacity of B is S, A is S over 2. When considering MS product, we can get that there is the same value for the MS product for both fluids. It means there is the same heat capacity. Therefore, when given same amount of heat energy, we can observe that temperature increasement of A is equal to temperature increasement of B. Theta A equals theta B, then answer is 1. At the atmospheric pressure, the specific latent heat of fusion of ice and vaporization of water are 3 into 10 to the power 3. It should be 3 into 10 to the power 5, not 10 to the power 3. It should be 10 to the power 5 and 20 into 10 to the power 5 respectively. If the specific heat capacity of water is 4 into 10 to the power 3, the minimum amount of energy required to convert 1 kilogram of ice at 0 degrees to steam at 100 degrees under the atmospheric pressure is. There are 3 types of heat absorption. First one is melting ice. It is a phase change. We have to substitute it, we have to use ml. There is a phase change. Then vapor made by melting ice should be increase its temperature up to boiling point, 100 degrees. It is an energy ms theta type, increase in temperature. And finally, we have to add ml. It is a phase change. Water is converted into vapor, vaporization. Now mass is 1 kilogram. Latent heat of fusion, we have to consider 3 into 10 to the power 5, not 10 to the power 3. Mass 1 kilogram. Specific heat capacity is given as 4 into 10 to the power 3. Temperature increasement 100 degrees, 0 to 100. Again ml, it is latent heat of vaporization. Mass 1, 20 into 10 to the power 5. We have to simplify it. We can obtain 27 into 10 to the power 5 joules. Then answer is 1. An electric heater is used to raise the temperature of water from 20 degrees to 30 degrees and supply hot water at rate 1 kilogram per minute. The minimum power of the heating element is, specific heat capacity of water is given as 4200. When considering minimum power, we have to consider that there is no heat loss to the surrounding. Then we can get power should be equal to ms theta divided by time. Total energy given by the heating element is converted to heat energy of water. Mass 1 kilogram per minute. Specific heat capacity 4200. Temperature increasement 20 to 30. It means 10 degrees. It is for 1 minute. Then we have to divide by 60 to get 1 second. Then we can cancel out it. 6 divided by 6, 170. It is 700 watt. Minimum required power is 700 watt. Then answer is 3. Heat is supplied at a constant rate to a certain amount of ice. The variation of temperature theta with time is shown in the figure. If the specific heat capacity of ice is C and specific latent heat of fusion of ice is L, T1 over T2 ratio is. We can consider the given graph. It is like this. This time interval is given as T1. This time interval is given as T2. This axis is theta, Celsius, temperature. This axis is time. Then we can get, they have given heat supply is at a constant rate. Therefore, heat used for increase temperature for ice, it is ms theta type. ms theta value is minus 20 to 0. Then ms theta value is mass into specific heat capacity into temperature 20. Divided by T1. We have to get rate. It should be equal to heat used for melting. Then it is ml type. ml divided by T2. We can cancel out m and m. S into temperature increasement of ice minus 20 to 0, it is 20. Divided by T1 equals L divided by T2. We have to get the ratio T1 over T2 over T1. Then I will subject T2 over T1. It is L over 20S. They have given specific heat capacity as C. Therefore, we have to use C. Normally, I am using specific heat capacity as S. 20 over L over 20C. They have used capital L. It's okay. Then answer should be 4. 10 gram of steam and 100 degrees Celsius is mixed with 10 gram of ice 0 degrees. The final temperature of the mixture will most likely to be. We know that heat exchange for the vaporization is a large value than the melting. We can consider this question. Latent heat of fusion is 3 into 10 to the power 5. Latent heat of vaporization is 20 into 10 to the power 5. Therefore, when mixing vapor and ice, we can observe temperature of the mixture should be greater than the mid value. Therefore, greater than 50 degrees, then we can get 6 one is the correct answer. When a certain amount of matter is heated at a constant rate, the variation of its temperature theta with time t is given by the curve shown in the figure. Consider the following statements made about the information that can be gathered from this curve about the matter. First statement, matter shows the change of state with temperature. Yes, it is correct. We can observe that there is a constant temperature time period like this part. It is a phase change. Then statement A is correct. In statement B, matter should have large value for its specific latent heat of fusion or vaporization. Yes, we can get it as a correct statement. There is a large time interval, therefore it should be a large heat exchange. Then part C, matter definitely has attained its boiling point. No, we can't. They have not given x-axis, time axis is unit. Therefore, we can't decide that it is a large time. Therefore, statement B is incorrect. Then statement C, matter definitely has attained at boiling point. No, it could be boiling point or melting point. Then C also incorrect. Only A is true. Answer is 1.